we're going to look at some examples of inequalities involving absolute values. So here we have an absolute value of x is less than or equal to 6. So if we pick some values here on the number line, so here 6 in absolute values is less than or equal to 6. That's true. So that point should be included. 7 in absolute values is not less than 6. So we should not include that value. Same thing with 8. 8 in absolute values is not less than 6. So we should not include that value. 0 in absolute values is less than 6. So we should include it. If I take minus 1 and put it in absolute values, it is that's equal to 1. And 1 is less than 6, so I should include it. Same with minus 5. Minus 5 in absolute values is equal to 5, which is less than 6. Minus 6 in absolute values is equal to 6, which is equal to 6, so I should include that. However, at minus 7, in absolute values, that gives me 7, which is not less than 6, so I shouldn't count that value. So the values that I should count are between negative 6 and 6. So when we have an absolute value inequality, I can rewrite it when the inequality is towards the points towards the absolute value. Then I can rewrite it as a compound inequality. So the absolute value of x less than or equal to 6 can be read as minus 6 is less than or equal to x is less than or equal to 6. Okay, so let's look at an example. X plus 7 is less than 10. So that means that this inside could be anywhere from minus 10 to 10. And so now I've converted my absolute value inequality into a compound inequality. So I subtract 7 from the middle and the two ends, and I get minus 17 is less than x is less than 3. So I find minus 17 and 3 on the number line. It's a strict inequality, so the endpoints are not included, so they're open circles and then color in between. So I get minus 17 to 3. Here I have the absolute value of 4x plus 1 is less than or equal to 3. So that says that this inside can be anywhere from minus 3 to 3. So I rewrite my inequality as a compound inequality and remove the absolute values. So now I subtract 1 from both sides. Well, subtract 1 from the middle and the two ends. So I get minus 4 is less than or equal to 4x is less than or equal to 2. Now I divide by 4 in the middle and on the two ends. And I get that minus 1 is less than or equal to x is less than or equal to 1/2. And so on the number line, there's minus 1, 1/2, and it's in between. So the interval is minus 1 to 1/2, square brackets on each. Now, it's possible that the absolute value of x could be greater than a value. So if that's the case, well, from minus 3 to 3, all of these values are going to be less than x. Or if x is one of these, it's going to be less than 3. So we don't include this middle part. But if I pick something bigger than 3, then in absolute values, it's bigger than 3. If I pick a value that's negative and less than negative 3, then when I take its absolute value, it turns out to be bigger than positive 3. So when I have absolute value of x greater than a value, a positive value, then I get this this number line with a hole in the middle, with a gap. And so we saw earlier about writing inequalities that had two pieces of, or writing down an answer that had two pieces of a number line. So we need to do that for when we solve absolute values and it's greater than. The inequality opens towards the absolute values. So we would read this as x is greater than 3, that's this part over here, or x is less than minus 3, which is this part over here. Then when you take the absolute value, it becomes greater than positive 3. Okay, so let's look at some examples. X minus 2 is greater than or equal to 5. So x minus 2 could be greater than or equal to 5, or x minus 2 could be less than or equal to minus 5. Then when I took the absolute value, it would be bigger than positive 5. So I add 2 to both sides over here. X is greater than or equal to 7. Or add 2 over here. X is less than or equal to minus 3. So I draw that. Here's minus 3. Close circle, and it's x less than. 7. Close circle, x greater than. So it's minus infinity up to minus 3, union. Oh, it's supposed to be a square bracket. And 7 to positive infinity. Last one. 3 minus 2x is greater than 9. Okay, so 3 minus 2x could be greater than positive 9, or 3 minus 2x could be less than negative 9, and then in absolute values it's bigger than 9. Okay, so start off by subtracting 3 on both sides. So I get minus 2x is greater than 6. Divide both sides by minus 2. Now since I'm dividing by a negative number, I'm going to flip that sign. So it becomes x is less than minus 3. Repeat the process, subtract 3 from both sides. So I get minus 2x is less than minus 12. Divide both sides by minus 2, and I flip the sign since I'm dividing by a negative. And then so I get x is greater than 6. So here is minus 3, here is 6. I get x greater than 6, strict inequality, so open circle. X is less than minus 3, strict inequality, open circle. And then I write the interval. So it's minus infinity up to minus 3, union with minus 6 up to positive infinity. And there we go.